this would be for lesson number 19, something called the difference quotient. As far as the mathematical indications of what this means, we really don't care today. All we really want to know is what is it and what am I supposed to do with it. So, the difference quotient, by definition, looks like this. It's the limit as some h approaches 0 of f of x plus h minus f of x all over h. This is the definition of the difference quotient. By definition. Now, what is f of x? Where f of x is any function of x. Is a function. This is the... Oh, crap. Okay. Now, a typical question in your homework should be something like, find the, I'm going to abbreviate it, difference quotient of, let's go, f of x is equal to 2x plus 1. Again, we don't really care today about what this implicates. We just care about what is it and how do I find it. Here's what it is. It's the limit of this bad boy, and that is basically it. This is just basically a big plug in and play problem, meaning I'm going to plug this into where it is. Now, what we're going to write is the limits. I'm just following the definition. The limit of h approaches 0. Now, this says f of x plus h. I wish I could see. I'm using my phone to film this. I wish I could see what I'm doing. Okay, so this is f of x plus h, and this is f of x. So what I'm going to write here is not 2x plus 1, but what's going to replace the x? That's right. Instead of x, it's x plus h. Note the parentheses right here. There is parentheses right there. So again, it is 2x plus 1, but instead of x, it's 2x plus h plus 1. And then this is going to be minus f of x, which is 2x plus 1. Now, as a safety, we're not going to just write 2x plus 1. We're going to write parentheses 2x plus 1. All over h. So our answer would be computing this limit if it exists. Now, it's pretty bizarre looking, but what we're going to do is try to simplify this as much as possible. So again, the goal is to compute the limit, or evaluate the limit. In other words, plug in h equals 0. However, we can't. Why can't we plug in h is 0 now? I'm pointing at it. You put the 0 now, you will get something undefined. I should probably zoom out just in case you are taking notes. So then we need to do some simplifying if it is possible, like on last night's homework. So I'm rewriting the limit again, because I'm going to do some distributing and like terms and stuff. What we get is 2x plus 2h plus 1 minus, minus what? Haha, you probably said minus 2x. Did you say plus 1? I hope not. It's minus 1, sucker. And we get it all over h. Again, all I did was distribute this thing to see if anything will possibly cancel. And I don't think... I saw it. Did you see it? I see it. That's gone. That's gone. That's gone. And that's gone. All we're left with is 2h all over h. That did not line up nicely. And you might think, okay, can I plug in 0? You technically can't. But what we can do is also cancel the h's, and now you have the limits of h approaches 0 of just 2. Now, there's really nothing to plug in, meaning the limit of a number, the limit of any number with nothing to plug in just gives us 2. In this particular case, there was nowhere to plug in h, so that's actually a sidebar. Note, the limit of anything, of any constant or any number, we'll call it a, is always just equal to a in this particular case. So if I would put something in notes, would be that thing. Okay. My answer would just be 2. The limits of what we just plugged in and simplified would just be 2. Of course, we could try something more complicated. This would be part B. I'm literally like behind my tripod, like with my right hand. It's so weird. Anyway, we are going to take this function, a different function. Let's go 2x squared minus x. I want to find the difference quotient of that. Okay, if you look back at the notes you just took, by definition, the difference quotient is the limit as h approaches 0. Again, don't worry about what h means. We're just using the definition, and that's it, and finding the limits of this. We get the limits of 2 parentheses x plus h squared minus parentheses x plus h. All over, minus f of x, which is just 2x squared minus x. I always put a parentheses around the last part because I want to remember that I'm distributing this negative sign. Again, so this is 2x squared minus x, so it's 2x plus h squared minus parentheses x plus h. Again, replaces this, replaces this. I'm going to draw arrows because there we go. And it's all over h. H for holy cow, I'm teaching in my kitchen. Okay, anyway. Now, this looks obviously a lot more complicated, and you're wondering how we might simplify this. Well, just like what we did in the other example, we're going to multiply everything out.
4 years ago,
hold on.
Top of the bill in Norfolk.
Alexa, stop. Okay, we're going to multiply the whole top out. This becomes, again, I'm always going to rewrite the limit every time I'm doing something different. I'm going to write a big fraction sign again. This becomes 2x squared plus 2xh plus h squared minus x minus h minus 2x squared plus x. Ooh, I almost fell for it. All over h. Okay. Looks fine. Okay, so far. All we did was distribute that. Oh, there's one more thing we could distribute. This is definitely tedious. However, nothing mathematically complex. All I'm doing now is distributing more stuff. Again, the goal. Plug in h. But we can't yet. H still down here. So something's supposed to happen where this h will cancel. But if you look super closely, things are going to start to cancel. Oh yeah. And then, what else? The x's. Yep. The x's, and look very closely. Anything else can cancel right now as far as combining like terms. I don't think anything else. So what we get, rewrite that limit again. 4xh plus 2h squared minus h all over h. Can we plug in h now? We cannot. Because that H is still down there. However, I see it. Do you see it? An H can cancel here, here, and here. It's gotta go in all three of them for this H to cancel at all. If this was like a 9 or a G, we can't cancel anything. You can't cancel part of it because this plus and minus sign. So what happens there is this is gonna go, that's gonna go, that's gonna go, that's gonna go. Leaving us with 4x plus 2h minus 1, the limits as h approaches 0. This whole thing turns into this. Now I ask ourselves, goal, plug in h. Oh, we now can. Plug in h is 0. And what do we get? Our difference quotient is 4x minus 1. Okay. Hopefully should be good to go for at least tonight's homework, which is number 19. The difference quotient. Okay. Still debating whether or not I should upload these notes. I probably should, but I think listening to it is good too. Please look at my answer keys. This is Mr. Viernes signing out.